Good day, everyone. So we want to quickly solve this problem. Solve the equation 8 raised to the power of x over 2 is equals to 2 raised to the power of 3 over 8 times 4 raised to the power of 3 over 4. You have to solve this. Please, this is an equation because of this equal to. Please don't solve it like you're solving expression. Some students are very funny. So now, you know that this is an equation involving indices. So your goal is to make sure that the base on the either side of the equation are equal. So what am I going to say? What am I going to do? We know that we can achieve that by just breaking down. So any base that is not a prime number, I will break it down. Look at this 8 now. It is not a prime number. I'm going to break it down. Look at this 2 at this right hand side. It is a prime number. 2 is a prime number. So I'm not going, you can't even break it down again. So that's just it. Look at this 4. This 4 is not a prime number. So I'm going to break it down. So that's the first thing I'm going to be doing. And by now, everyone should be familiar with what we mean by breaking down. So now, what we mean by breaking down is actually when you say 8, you do like this and say 2. 2 in 8 is going to be what? 4. 2 in 4 is going to be 2. And 2 in 2 is going to be 1. So you're going to have 2 raised to the power of what? 3 is equals to 8. So anywhere you see 8, you can put 2 raised to the power of 3. So that's what I mean by breaking down. And you can break down 4 as well to be 2 raised to the power of what? 2 raised to the power of 2. So now, let us do that and see what we're going to have. So the solution is going to be like this now. Solution. So this 8 now I'm going to write 2 raised to the power of what? 2 raised to the power of 3. But there, before, the 8 has the power of x over 2. So I'm going to put it in brackets and say x over 2 is equals to, now at the right hand side, I actually have, I'm going to write 2 raised to the power of 3 over 8 because I can't break down one down again. So I have that. Then times, this 4 is actually 2 raised to the power of 2. But that 4 has 3 over 4, so I'm going to put open bracket 3, 4. Close bracket. Now, the next thing is that I'm going to say this, everyone. I'm going to open the bracket so I can say 2 raised to the power of 3. Now, the bracket I'm going to turn into times now. That's x over 2 is equals to, now this right hand side, remember that we have to make the base to be equal. Now, if you check the left hand side here, the base is 2. Fine. The right hand side also, the base 2. But please, before we can say, okay, the next step ought to be that we should equate the power. But before you equate the power, please make sure you have something like this, like you're having just a single base at the either side. Some people might not know what I mean by single base. I'm just saying that let's say you have 2 raised to the power of x is equals to 2 raised to the power of what? 2 raised to the power of 2. Something like this. Not that you're going to be having something multiplying. Maybe you have 2 raised to the power of x equals to 2 raised to the power of 2 times 2 raised to the power of 3. You cannot equate the power by now. So you have to apply a law that you can see here to make sure that it is having a single base. So that is what I mean by make sure that you have a single base before you equate the power. So now let's just move on. So what we are doing now is that this right hand side here, we are going to apply law of multiplication. You can see this multiplication in between this. So you are going to apply the law of multiplication to solve that first. So you're going to pick one base. You can remember that. Pick one base. The power of the first one is actually what? It's actually 3 over 8. So now multiplication in indices means plus of the power. Then the second power is actually 2. Now, the second power is actually 2. Okay, let me say, okay, 2. I'm thinking of multiplying everything first. But now let's go to, okay, now let me show you this. These 2 here, these 2 that I'm pointing at here, if it is going to multiply this 3 over 4 here inside this bracket. So let me do the multiplication here so I can substitute. So I'm going to have like 2 times 3 over 4. And you can see 2 here 1, 2 in 4 is what? Is 2, right? So I'm going to have what later? I'm going to have 3 over 2. So that's what I'm going to put right away. So that is what, so that you'll not be asking how I got that 3 over 2. So I'm going to have then 3, I'm going to have 3 over 2 here. 3 over 2. Okay, 2 raised to the power of what? 3 over 2. So now, sorry, it's actually 3 over 2. We have applied the law of indices. So we picked one base. So after picking one base, then we added the power because of the law of what? Because of the law of this multiplication, right? Good. So the next thing is that this power, the power of these two at the right hand side, I'm going to add that somewhere. And this one at the left hand side, I'm going to multiply that. So what I'm going to be left with, let's continue from here. I'm going to be left with 2 raised to the power of, now let's do this power. We have 3 times x over 2. So that's going to give us 3 times x. That's going to be 3x over what? Over 2, right? So this one is going to be 3x over 2 is equals to 2 raised to the power of what? 2 raised to the power of what do we have at the right hand side? Don't forget what we have at the right hand side is actually 3 over 8. 3 over 8 plus 3 over 2, right? Yeah, I think that's what we have. So we are going to apply LCM. So you say the LCM of 8 and 2 is actually going to be what? It's actually going to be 8, right? So once you do that, then you now say, you go back to your fraction, say how many 8 are you going to see in 8? It's going to give you what? It's going to give you 1. So 1 times the numerator, which is 3, 1 times this 3 is going to give you what? It's going to give you 3. So you're going to write your 3 like this. Then the addition sign, you put it. Then go to the second fraction here also. How many 2 are you going to see in this 8? 4. 4 times the numerator, which is 3. 4 times 3 is what? 12, right? Good. So 2 in 8, it's 4. 4 times this 3 is what? Is 12. So I'm going to write this 12 like this. And you can see that you can now add 3 plus 12 is going to give us what? 15 over what? 15 over 8. So once we have that, then we can substitute that 15 over 8 at that side. So 15 over 8. Don't forget our power will be 15 over 8 for this side. So I'm going to have 15 over 8 here. So once I have the 15 over 8, then the next thing I'm going to do is that look at the base now. The base at this left hand side is 2. The base at the right hand side is 2. And they are single base, not that you are adding anything or you are subtracting or you are multiplying. So please, because the base are the same now, equate the power. That's the next thing. Equate the power. So what do I mean? I mean by saying that 3x over 2, the power of this left hand is equals to the power of the right hand side over 8. So, and next thing to do is to what? Scissors method. So I'm going to apply my cross multiplication right away. So that would be what? 3x times 8 is equals to 15 times what? Times 2. Right? Good. So 3x times 8, that would be 3 times 8 is what? 24, right? So I'm going to say 24x is equals to 15 times 2 is going to give us what? It's going to give us 30. So I'm going to, well, I'm not looking for 24x. I'm looking for x. So I'll divide both sides by 24. So I'll say 24x divided by 24 is equals to 30 divided by 24. So this 24 will cancel 24. I'm going to have x equals to, now 24 can, well, I'm going to reduce this 30 over 24 to the lowest end first. So 2 can go in 30 and 24. So I'll say 2 in 30 is what? It's 15. And 2 in 24 is what? Is 12. Right? So I'm going to say 15. Right? I'm going to say 15 over 12. That's equals to 15 over 12. But it seems something can still divide them. Well, 3 can go in 15 and 3 can go in 12. So I'm going to say 3 in 15 is what? 5. Then, and 3 in 12 is what? Is 4. So I'll say finally that my x equals to 5 over 5 over 4. And that is the solution to this problem. Thank you.